My name's Ton van den Bogert. I'm a professor in mechanical engineering at Cleveland State University. And what you see here behind me is the V-gate system that we use for mechanical testing of human motion. As you can see, it's a very realistic environment that we can create. And we use virtual reality technology to present a 3D environment visually in front of the person. And then the treadmill itself can also, of course, create a walking speed or a running speed. It can also create uphill or downhill, and it can also move sideways to introduce disturbances. And then while we have the person in that sort of environment, we can record motions with our motion capture system. We're also recording forces between the foot and the ground with sensors that are placed in the treadmill. And then there's a very sophisticated mechanical analysis that we do to determine the kinematics of the motion. We can also determine the torques that are being produced in the joints, and we can even determine forces that are being produced by the muscles. So we get a very, very detailed mechanical picture of what the human is doing during this exercise. And then that information can be used to answer all sorts of questions. You can think of diagnostic purposes. So we can put a patient on here and determine which muscles are not functioning normally and do something with that information. There, you see how our right calf muscles are lighting up? And that's a calculation that we've done that shows how the muscles are used. Now, stand on your toes, both feet at the same time. The muscles will light up in the same way. Let's see if we can do something with the arms. You raise your arms, we should see your deltoids light up. Yep. Yep. Yeah. That works really nicely now. I think what we're going to do is do some walking. So here we see the muscles in the front, and you see even the trunk muscles are being used in walking. You can look at it from any view here. It's almost like you get an X-ray picture of muscle function, which is a really unique thing to have. Normally a doctor would look at somebody walking and they would try to figure this out in their head, what's wrong with the muscles, but here we can actually measure it and present that information in the form of a graph or a picture or numbers. The other thing that we are going to be doing with this is determining how humans control their movement. So for instance, when there's a disturbance, humans react to it because they don't want to lose their balance. We would like to develop prosthetic limb technology that has the same capabilities, which does not exist right now. What we would like is to have prosthetic limbs that have their own brain and that react as if it was still a normal limb. So if there's a disturbance, it would actually help you balance yourself, and it would react normally, and it would function as if it's still a part of your body. The other technology that we're working on, and that's with the Parker-Hannifin company, is an exoskeleton. So that's a robotic limb that is attached to your own limb. If you're paralyzed, then it can help you move. And you need exactly the same capability, that this limb needs to be smart enough that it performs the movement and that it also responds to perturbations in the mechanical environment. So if you step in a hole in the ground, that you don't lose your balance, but the limb helps you recover from that. Okay, so what I've done here is this. This is an example of an application where you can control things with your body mechanics. So this ball is now being controlled by her quadriceps forces. Whenever she uses her quadriceps on the left or the right, the ball will go up. But if she uses the left more, the ball will go to the left. And if she uses the right more, the ball will go to the right. So try doing some squats with the ball just goes up and down. So if you don't use your muscle on one side enough, then the ball will tend to go sideways. So this would be a really good way to teach people to do symmetrical exercise, and especially if you've had a stroke and you're weak on one side. You would do these squats and you would see the ball go sideways, and you're trying to control the ball so it only goes vertical. So this is an application where the virtual reality system is used to simulate a walk on the road. And the road is programmed into the computer. When the road goes uphill, the treadmill will go uphill. And she can hit the birds with markers on her hands. And each time she hits a bird, she gets a point. This technology can be used to answer any question about human motion. It allows us to record all the variables, joint angles, joint torques, muscle forces. And there are several graduate students who work on projects that use this system. One student is going to work on developing a control system based on experiments on humans. So there will be humans walking on the treadmill while we're introducing all sorts of random perturbations, and it's going to be recorded how they react to that. And then there will be a mathematical analysis to determine what sort of control system would be needed to replicate this human behavior. And once we've done that, then that can be put in a prosthetic limb. And that's an example of the type of projects that students can do with this system.